Okay, we're going to talk about rational expressions and radical expressions because there is a connection between the two, right? There is a relationship between rational exponents, or you can be known as fractional exponents, and radical expressions. And the relationship is, I call flower power. And I learned this, and it works so well, and I love doing this. Now, I want you to remind you and tell you, because I always tell my kids in class, my mother's an artist, I didn't get any of those genes. So the following picture isn't very pretty, but hopefully will illustrate. So let's look at this. Okay, so let's talk about flower power. And we're going to talk about what it means to have a fractional exponent and how to rewrite it. So let's look at the first one. Here is my symbolic form. I have x to the a over b, so I have a fraction. You can write it with a radical symbol. The x would go underneath the radical symbol, and then the a would go next to the x, and the b is outside. So this is your power, and this is your root. Or you can write it with the b as your root outside, x, and the a can be out here by the radical. So either one of these will work. So this is the same as this. This is the same as both of these. So you can write it as a fraction, or you can convert it into a radical. Okay? Now, I used to always mix this up in school. I never knew where the A went and the B went, and I didn't know how to do it until I had a professor that had this huge poster on the wall, and he called it flower power, and it worked so good. So here's my beautiful flower. It's blue. It's in a pot here. So I wrote the word flower here, and I took that fraction and I blew it up so it's really big right here, okay? Do you see how the A is the same as the flower? They match up. So right here's a line for the flower pot. Well, the flower goes with the A. So this is my flower, so A is the power. That's where the flower power came from. The flower power. So the power's on the top of your fraction. On the bottom, there's roots here. See all the roots in my pot, in the dirt? Well, this is my root, and that's where the root goes. So anytime you look at that fraction as a little tiny flower pot and say, oh, this is my flower power, that's my root. Then you'll go, oh, I know that the root has to go on the outside of my radical, and the power goes here, or it can come on the outside there. So it's really neat. So it's flower power. So the top of it is power. Let's practice a few so that you can see how to rewrite these. All right? So I have 4 to the 5 halves. Right? The instructions are rewrite as a radical expression and simplify if possible. So let's write this as a radical. So I'm going to do this. I know there's a radical. Here's my little flower pot. So it's 4 to the 5 halves. So 5 is the flower power. So that's going to go with the 4. So the 4 is going to come in here. So I'm going to put the 5 with the 4. And then this is the root, and I can put it on the outside. Now, if you'll notice, I didn't write the 2 there because square roots, or the 2, is understood. Now, you could write the 2 there, but usually you'll never see it unless it's a cubic or a 4 or 5, anything else besides a 2. So a 2 is understood. So you can rewrite it like that. Or I could rewrite it like this, radical 4 with the 5 here. And sometimes that comes in handy because the square root of 4 is 2. That's 2 to the 5th, or it comes out to be 32. Now, I know that you can put 4 to the 5 halves in your calculator and come up with 32. But there's going to be time when you need to show your work and you got to convert back and forth. I'm going to ask you how to write it the other way. This, if you put that in your calculator, you get the same answer. Now, the other thing I want to caution you and to show you also is, look, it's 4 to the 5 halves. 5 halves is improper. It's like 2.5, okay? So I know my answer is going to be bigger than 4 because I'm raising it to a power that's greater than 1. And it is quite a bit bigger than 4. So look at that. If it was 4 to the half, it'd be a smaller, and it'd be an answer that would be smaller than 4. So I want you to use your common sense and just not be a robot, but to look how to do this. Right? Let's look at 2. I have a to the 3/5. How would I rewrite that? Well, here's my little flower pot. Write your radical. A is going to go here. My flower power goes here, and the 5 will go out there because it's the 5th root of a cubed. Okay? Our third example is 3x to the negative 2/7. Well, before we do this, we got to write this with positive exponents. So we're going to just take this downstairs. I'm going to put this is going to go downstairs. So this is going to be 3x to the 2/7. How come the 3 didn't go with it? Well, because the 3 is here. The only thing raised to the -2/7 is the x. So don't take them both together. This really, if you think about it, is raised to the first power, just a +1. So that's going to stay in the numerator. Now, how do I rewrite that? Well, that'll be simple. The 3 will come here. I write my radical. The x will go in there. There's my little flower pot. So it's going to be x squared, the 7th root of x squared. So that's how you would rewrite that. 3 over the 7th root of x squared. Okay? Number 4. I have 4 over y to the -6/5. So you're like using all the rules that you've learned before. So let's take that upstairs. So that's really 4y to the 6/5. Okay, so it's positive. Now let's rewrite it. The 4 is separate, and I have a radical. The y will go in there. Here's my little flower pot. Here's my power, flower power, so it's going to go here, and it's going to be the 5th root. So I have 4 5th root of y to the 6. Okay. Let's try some more examples. Now we're going to go the other way. So I could give it to you in radical form and say, please write this with fractional exponents, or rewrite it a different way. And you've got to make sure that you remember the flower power, because that will really help you. So let's look at the first one. I have the cube root, so number 5 is, the square root of x cubed y. How do I know it's a square root? Because there's nothing there. So it's understood there's a 2. So if you want to write the 2 there just so it'll help you out, now I want to rewrite that. Well, I have to write a lot of little flower pots now. Well, this is my power, that's my root, so I can write it as x to the 3 halves. And if I were to write that, I say, oh, that'd be x cubed, the square root of x cubed. So you're like going backwards, all right? Now here I have a y, so I know I've got a y. How would I write that? Well, if you need to, put a little 1 there, because that's understood. And I have to make a little flower pot, so there's my flower power, there's my root, so that's y to 1/2. That is exactly the same as the square root of x cubed y. All right, let's look at this one. I have the 4th root of 81a squared b. Okay, and I picked this on purpose because the coefficient causes problems. If you need to, put a little 1 there. So now we're going to make a bunch of little flower pots. So I have 81 to the 1/4, a to the 2/4, and b, you guessed it, put a little 1 there, to the 1/4. Now simplify this. Well, 81 to the 1/4 is the same as the 4th root of 81. Okay, what do you say 4 times to make 81? Well, it's 3. And you can put that in your calculator if you need to. I can reduce this to a to the 1/2, b to the 1/4. So right here, I took that and wrote it with, and simplified it and wrote it with rational exponents. So this is fun. Flower power. Remember that. Okay, let's look at this one here. I have 7 cube roots of d to the 5th. So let's rewrite it. So I have 7. How would I write the d? There's my flower power, there's my root. So make a little flower pot. And that's all I would write. So that gives you a little taste of how it is to go between writing as a radical to rational exponents and the other way around.